I'm Anil Kumar sharing with you few questions on rate of change. The question here is, a ladder 5 meter long is leaning against a wall. The ladder is sliding down the wall. The ladder is moving out from the base of the wall at 1.5 meters per second. How fast is the ladder slipping down the wall at the instant when the bottom of the ladder is 3 meters from the wall? You can anytime pause the video, solve the question, and then look into my suggestions. So in all these word problems, we should first sketch. So let us say that is the ground and this is the wall. We are talking about a ladder which is 5 meter long leaning against the wall. So let's say the ladder is kind of like this. Length of the ladder is 5 meters. So that is this length, 5 meters. The ladder is sliding down the wall. The ladder is moving out of the base of the wall at 1.5 meters per second. Let us say this is x and that is y for us. So when we say out at 1.5 meters per second, that means dx dt is equals to 1.5 meters per second, correct? How fast is the ladder slipping down the wall at the instance when the bottom is 3 meters from the wall? So we have to find a rate of change of height in that case when the bottom is 3 meters. So if the bottom is 3 meters, hypotenuse is 5, height at that time will be 4, right? You can always find this by doing 5 square. We can say y equals to square root of 5 square minus 3 square, which is 25 minus 9, correct? Which is 16, and that gives you 4, correct? Now to find the rate of change of the height, we need to relate x and y, and we can do so using Pythagorean theorem, right? We can do so using Pythagorean theorem. So let's relate these two. So we have x square plus y square equals to 5 square. Now we can differentiate with respect to time. So if we differentiate with respect to time, what do we get? That is to say, we do d dt of x square plus d dt of y square equals to d dt of 5 square is 25. So that gives you 2x dx dt, right, plus 2y dy dt, and for a constant, derivative is 0. We need to find what dy dt is, so let's isolate dy dt. So we get dy dt is equals to minus, bringing this here, 2x dx dt, right, divided by 2y. So we'll divide this by 2y. So we took 2x dx dt to the right and divide by 2y. Now that could be simplified. 2 and 2 cancels. This is 2y. Okay. So we could rewrite this as minus x over y dx dt. Correct? Now, what we need to find is dy dt when x is 3, when x equals to 3. We also found when x is 3, y is equal to 4, right? Y equals to 4. And there is a constant rate of dx dt 1.5 given to us. So at this time, we can write this as minus x value is 3, y is 4, and dx dt is 1.5, correct? 1.5. The units will be meters per second. You can use the calculator and find the value, correct? Or let's write this as 3 over 2. You can write this as, let me do it in fractions. So minus 3 over 4 times, let me write 1.5 as 3 over 2. So we get minus 9 over 8 and the units are meters per second. So the top of the ladder is coming down, that minus means coming down, with the rate of 9/8 meters per second. Okay, so that's the answer for us. Minus 9/8 meters per second. I hope that helps. Thank you and all the best.